Ford just ended the EcoBoost nightmare, and the 2027 engine changes are bigger than anyone expected. If you have been holding off on buying a new Ford truck because of serious reliability concerns, you need to hear this right now. Ford has confirmed a deep mechanical overhaul for 2027, and engineers say this is not a patch job. It is a ground-up fix targeting the exact problems that damaged EcoBoost's reputation over the years. Let's get into exactly what went wrong with EcoBoost, what is actually changing inside the 2027 engines, and why industry experts believe this could be the most important powertrain comeback in modern American pickup truck history. When Ford launched EcoBoost back in 2009, the entire concept was genuinely revolutionary. The idea was simple but powerful. Take a smaller displacement engine, add turbocharging and direct injection, and you get V8 level power with V6 level fuel economy. And for a while, it worked beautifully. The 3.5-liter EcoBoost became a massive bestseller inside the Ford F-150 lineup. The 2.7-liter impressed buyers with strong torque numbers and solid towing capability across a wide range of real-world conditions. Even the high-performance Ford Raptor ran entirely on Turbo Fi 6 power. Sales exploded across trucks, SUVs, and performance cars throughout the entire Ford lineup. But as the miles started stacking up on these engines, the complaints began stacking up right alongside them. Let's separate the real mechanical failures from internet noise, because not every EcoBoost problem was exaggerated. First, coolant intrusion hit certain 2.0-liter and 1.5-liter four-cylinder variants particularly hard. Block design weaknesses allowed coolant to leak directly into the combustion chamber. Owners dealt with white smoke pouring from exhausts, persistent misfires, head gasket failures, and in the most severe cases, full engine replacements. Independent technicians traced much of this damage back to open-deck block architecture that simply could not handle sustained boost pressure over extended time under load. Second, carbon buildup became a widespread and frustrating problem across early EcoBoost generations. Because these engines relied solely on direct injection without any port injection system working alongside it, fuel spray never made contact with the intake valves during normal operation. That meant carbon deposits built up gradually over time, eventually causing rough idle, reduced throttle response, and noticeable power loss. This problem is not exclusive to Ford products, but early EcoBoost engines felt the consequences particularly hard because of how aggressively those engines were tuned from the factory. Third, timing chain stretch showed up across several 3.5-liter VCT engine variants in real-world ownership. High torque output combined with oil degradation accelerated wear on timing components faster than expected. Drivers reported rattling sounds on cold starts, illuminated check engine lights, and cam timing fault codes appearing without warning. Fourth, turbo heat stress became a genuine long-term durability concern, especially among owners who used their trucks regularly for heavy towing work. Early oil routing systems and cooling pathways did not always leave enough engineering margin built in for sustained high-heat operation over years of demanding use. Over time, that accumulated thermal stress caught up with some of these engines in costly ways. Now here is where things get genuinely interesting for truck buyers paying close attention. Ford's 2027 redesign targets every single one of those specific failure points directly. According to engineering sources and supplier updates connected to Ford's 2027 production plans, there are 5 major mechanical changes coming to the EcoBoost family. The first is a completely revised block architecture. Ford is moving towards stronger closed deck or heavily reinforced deck block designs across the affected engine families. This matters enormously because closed deck construction improves cylinder wall stability under sustained boost pressure. One powertrain engineer described it as a structural insurance policy built directly into high-boost engines. The risk of coolant intrusion and head gasket stress drops significantly with this kind of foundational structural reinforcement underneath. The second major upgrade coming in 2027 is dual injection, combining traditional port injection with direct injection working together simultaneously. This is a genuine game changer for long-term reliability. Direct injection keeps power output and fuel efficiency strong, while port injection washes the intake valves regularly with fuel during operation, preventing carbon buildup entirely before it ever starts accumulating. This system has already proven itself reliable inside performance applications across the industry. Rolling it out broadly across additional EcoBoost variants represents a serious, long-term durability commitment from Ford engineering. The third change targets timing components head-on. Ford is reportedly moving to heavier-duty timing chains across affected engines, upgraded tensioner designs, and revised oil passages engineered specifically for improved lubrication throughout the entire valve train system. Experienced mechanics have said for years that timing chain reliability ultimately comes down to oil quality and tensioner design working together. The 2027 revision goes after both of those factors simultaneously with purpose-built solutions. Fourth, thermal management receives a serious upgrade for 2027. Revised coolant routing paths, water-cooled turbo housings, and updated heat shielding all work together to keep operating temperatures under tighter control during demanding driving conditions. Managing heat effectively is considered the single most critical factor in long-term turbocharger longevity, and Ford's engineers are clearly taking that responsibility seriously heading into the next generation. Fifth, software and ECU calibration improvements complete the package. Ford's engineering team is reportedly smoothing torque delivery curves, reducing peak cylinder pressure spikes under certain operating conditions, and refining boost ramp rates through updated engine management mapping. These calibration changes reduce internal mechanical stress meaningfully without affecting real-world driving performance in any way drivers would notice. For truck buyers across America, this redesign carries serious implications. EcoBoost engines power the F-150, the Ranger, the Expedition, and the Explorer. For anyone hauling trailers regularly, logging heavy highway miles, or depending on their truck as a daily work vehicle, reliability directly impacts resale value, towing confidence, and long-haul peace of mind. If the 2027 overhaul delivers on its engineering promises, it fundamentally changes the conversation for every buyer who previously hesitated because of EcoBoost's complicated ownership history. Automotive engineers and industry analysts are broadly in agreement on several key points. Modern turbocharged engines are not inherently unreliable by design. The real issue with early EcoBoost was insufficient engineering margin. Those engines were pushed aggressively to meet ambitious performance targets, and in certain variants, there simply was not enough durability buffer built in for long-term real-world operation. The 2027 approach reportedly prioritizes longevity over peak output numbers, which is exactly the correction this engine family has needed. Analysts also note that Ford is protecting something far bigger than one engine platform. The F-150 has been America's best-selling truck for over 4 consecutive decades. Powertrain reputation is inseparable from that market dominance, and both GM and Ram are watching closely. This redesign is simultaneously a strategic business decision and a genuine engineering correction. Based on early information, power output should not drop in any meaningful way for buyers. Torque curves may become smoother in delivery, but peak numbers are expected to remain comparable to current production figures. Experts consistently point out that most catastrophic engine failures occur during extreme stress spikes, and smoothing those spikes even slightly can dramatically extend overall engine life without drivers noticing any real-world difference behind the wheel. The 3.5-liter reportedly gets stronger cylinder wall casting, an improved oil pump, and more durable cam phasers throughout. The 2.7-liter may receive updated head gasket reinforcement and a redesigned internal cooling channel layout. These are foundational architecture changes, not surface-level cosmetic updates. The real verdict on whether Ford has truly ended the EcoBoost nightmare will arrive through owner feedback collected over the next several years of real-world driving. But from a pure engineering standpoint, based on everything confirmed so far, this looks far more like a carefully calculated, confidence-restoring reset for the EcoBoost name than simple damage control.